This third problem we did in class today will illustrate again the 5-step process that we should employ with factor labeling to solve virtually all the problems in chemistry we'll encounter. Now, first step is to take all the data, and we have 3 pieces of data in this question, and write them down as numbers with units and labels. So we have 13.1 grams of gold, which I will represent with the symbol for gold, AU, for every 1 centimeter cubed of gold. This is a mass, this is a volume. The entire ratio is a density, of course. But I recognize this is a mass and this is a volume. That's important in step 2. The second piece of data we're given is a numerical price, a value of $10,500, and dollars are the units there, per 1 pound. Those are the units there, but of course the labels would both be gold because we're talking about the price of gold. And so, yes, once again, I have a number with a unit and a label, a number with a unit and a label. Lastly, we are simply given a price value of gold, $250,000 of gold. But still I have a number, a unit, and a label. So I've completed step 1, transferring each of the given values to the paper as numbers with units and labels. I reiterate again in this conversation that the labels are unimportant when everything in the problem is about gold, but we're soon going to encounter problems where you're not talking about the same thing throughout the problem, and the labels will become essential. Anyhow, step 2 is to ask what quantity is being requested. Now, it's asking me how many of these things, cubic feet, but that's not a quantity, those are units. But cubic feet are units of volume, so I'm being asked for a volume of gold. Well, this is a price of gold. This too is a price of gold, and this is a mass of gold. This is a mass of gold, so this is the only volume of gold I see in the problem. So if I want to start with the right answer, which I want to do in all of these problems, I need to take that volume of gold and begin the problem with it. Now the reason I inverted this density, flipped it upside down, is if I didn't do this and I left the volume of gold in the denominator in a string of numeric values, when I multiplied through and isolated this on the bottom of a fraction, I would end up with a number over volume of gold. And 1 over a volume is not the same thing as a volume. I need the volume to be in the numerator to get the volume. I have written the density so the numerator's in the volume. That's what I'm trying, or the numerator has the volume, and that's what I'm trying to get. So step 4 then becomes eliminating any quantities you don't want. And this mass of gold I do not want, so I have to cancel it. And the only way to cancel a mass of gold is by using a mass of gold. Well, this is a price of gold, and this is a price of gold. But this is a mass of gold, and by inverting this, turning this upside down, I could get the mass of gold to cancel the mass of gold if the units were the same. But these mass units, grams, are not the same as those mass units, pounds. So the first thing I have to do to these units is convert them to pounds of gold. And that's a straightforward conversion. 10 to the 3rd grams of gold are equal to 1 kilogram of gold. And I did that first because my link to British pounds is through kilograms. 1 kilogram of gold is 2.20 pounds of gold. And if I cancel as I go along, I see that I now have denominator units of mass that are in pounds of gold. And now I can use these pounds of gold given in the problem to cancel those pounds of gold. However, I'm not going to write it this way. I won't write it this way. This is what not to do, and I'll show you why. If I did that, I would be multiplying pounds times pounds, and I get pounds squared in my denominator. and I would have cubic centimeters and dollars in my numerator. So I'd literally have cubic centimeter dollars per pound squared, and I have no idea what that is. Now I want to cancel the pounds of gold with pounds of gold. And the only way I can cancel pounds of gold with those pounds of gold would be to invert this ratio, flip it upside down. 1 pound of gold equals $10,500. And pounds of gold now cancel pounds of gold. And yes, if $10,500 equals a pound of gold, then 1 pound of gold equals $10,500. How I write this ratio is purely convenience. The thing that I want to cancel is how I write the ratio. But now I have canceled the mass of gold, but I still don't have my answer all by itself because I've introduced a new quantity, the price of gold, dollar signs right there. And so, of course, I need to cancel price of gold, and the only thing that cancels price of gold would be a price of gold. There's a price of gold right there. And if I were to multiply by that value, then the units and the labels both cancel, and the only remaining units and label are volume units for gold. And so I've completed step 4. I've isolated the quantity that I wanted and started with, and there are no other quantities. However, step 5 is to check units. This problem specifically wanted cubic feet of gold, and we currently have cubic centimeters. So I have to do a couple more steps in converting centimeters cubed to feet cubed. The connection is through inches, because if you cube 2.54 and cube centimeters, they're equal to 1 cubed and inches cubed. And the centimeters cubed of gold, and I should leave my labels, I shouldn't stop using them, cancel. And I now have inches cubed of gold. If I continue down here where there's more room, I need to cancel inches cubed and replace it with feet cubed. And 1 cubic foot of gold would equal 12 cubed, or 1,728 inches cubed of gold. Inches cubed in the denominator will cancel inches cubed in the numerator. So you take out your calculator and you divide 1 by 13.1, you multiply by 10 to the third, you divide by 2.20, you divide by 10,500, you multiply by 250,000, you divide by 2.54 all cubed, that's 16.4, and you divide by 1,728. And because we had a 3-digit measured number and a 3-digit measured conversion and a 2-digit measured number and a 3-digit measured number, we should have 2 digits in our final answer. And that final answer comes out to 2.9 times 10 to the negative 2. And of course our units now are simply feet cubed of gold. So yes, not a whole lot of volume of gold for $250,000 worth of gold.